Hey guys, my name is Boris and I am a computer engineering student currently studying in my 5th bachelor semester at the Technical University of Berlin. And on this channel I want to talk about things that I've learned and might bring you value, additional educational topics, or even a few lifestyle topics. Now in this video we will take a look at what you could be learning in a computer engineering degree. In particular, we'll continue taking a look at the 4th semester of the Technical University of Berlin. This is the first semester where you have modules that you can choose freely. You basically have only 2 or rather 3 obligatory courses. And let's get started with those. Now in circuits technology, you will have an approach to solving networks similar to the one in the course electrical networks. But you will mainly focus on designing circuits with transistors to build different electrical components. For example, the main component will be an operation amplifier. You will again take a look at the MOSFET and 3 modes. It has the subthreshold mode, the triode mode, and the saturation mode. Now, if you have a good understanding of those, based on previous courses, for example, a semiconductor course, this will be a little refresh, but it is a fundamental skill that you have to know, or know how to work with those, and the equations that come with those modes. So the annoying part with the MOSFET is its nonlinear property, which makes it hard to calculate. For that reason, you will learn an approximation algorithm to break down or transform a MOSFET circuit into a small signal substitute circuit. Small signal because you have the assumption that your input voltage, the gate voltage, will not change that much. And with that you can basically again calculate the transfer function, or in this case it's rather considered the amplification. Later on you will obviously also take a look at the big signals and what effect they have on the output voltage. You will mainly work with MOSFETs, but you will also briefly take a look at the bipolar transistor and how to build circuits out of those. It's a pretty similar process. For example, you may be looking at the Darlington circuit, which basically behaves like a normal bipolar transistor, but with a much larger amplification. You will learn a few properties of the transistors, specifically the MOSFET, that change with different voltage ratios between the terminals, and basically do a bit more in-depth analysis of the transistor itself with those different voltage ratios. And from now on you will basically take a look at different circuits, as the name of the course may suggest, and how to possibly optimize those. For example, there are the transmission gate, the current mirror, which is important for the operation amplifier, and the differential amplifier, which, for example, also may consist of a current mirror. And finally, the operation amplifier, which consists of a current mirror, a differential amplifier, and an inverting amplifier at the end. Now, this amplifier is one of the core elements of this course. You will work quite a bit with it. For example, you will learn how to tweak the dimensions of certain transistors given other properties of the amplifier. And you may go through the circuit and look for the inverting input. After breaking down the amplifier itself, you will learn how to work with it as a component in a circuit. For example, you will take a look at how to implement a non-inverting or inverting amplifier, or a buffer amplifier, for example. You will have to recognize different little circuits in a larger circuit. For example, you have to know when you see a current mirror, or you have to know when it's a non-inverting amplifier or a buffer amplifier. And in the end, you will also take a look at larger scale circuits. Well, with larger scale, I mean not really big ones, but with 3 or 4 amplifiers, for example. And you will have to go through the circuits with an input signal and then describe the output signal based on the input. And in the end, there will be a tiny bit of logic because we are computer guys. All this isn't too hard, to be fair, and it's fairly practical. For example, a good friend of mine decided to build a little amplifier himself. Now let's continue with the hardware practical course. Now, as mentioned, this grade that you get here won't go into your final bachelor grade, but I want to mention that it will show up in your transcript. This also counts for the other courses that have no weight on your final grade. Now, this course itself, the hardware practical course, is pretty similar to the computer architecture practical course. To be honest, it's pretty much the same, just a bit more complex perhaps. You will again receive assignments where you have to implement hardware in VHDL. This time you will go through a 3-step process where you have to simulate, synthesize, and then test. A few topics that you may have to implement are, for example, registers or a clock, not the one that shows time on your wrist, a unit that shifts bits, or a serial interface, and so on. So overall, a rather relaxing course again. So the last mandatory course this semester is Principles of Theoretical Computer Science, or Principles of Electromagnetic Fields, or Principles of Statistic Information Theory. Now, I personally chose the theoretical computer science course, so I will be able to give a bit more in-depth look into this course in particular. But the course about electromagnetic fields is pretty maths heavy, that I can say. Similar to the principles of electrical engineering in your first semester. Now, if you're good in the maths from Calculus 2, you're pretty good to go. The information theory course is similar to the signals and system course, and it's by the same professor. But now to theoretical principles of computer science. You will again start with Boolean equations. By now you should have worked quite a bit with those. Perhaps the rather new thing is that you will be working a bit more in depth with quantifiers. For example, the inverted A or upside down A of x, the for all x do that. Then you will have a look at proofs. I know that sounds again quite annoying, but it won't take much space in this semester. There will be the reductio ad absurdum, it's just called like that, where you assume a thing and this thing will result in an absurd result. So that means that the statement you want to prove is wrong. Then you will meet the proof by induction again, and in the end there is the basic counter proof. The next bigger topic is relations, and later on there will be functions. Then you will get to know what an equivalence relation is, for example, and how to prove different properties of a relation. What is a reflexive relation or a symmetrical relation? It might seem like quite a lot in the beginning, but it really isn't that much, and it's pretty simple. Then you will get to functions, which basically are relations but with specific properties, and do similar things. Next you will continue with formal languages, so a set of rules which define which word is in a language or not. Imagine, for example, the rule where you have a language consisting of A's and B's, and the number of A's has to be equal to the number of B's. This might be a language. As with the to us known natural language, the formal languages also have grammar, and this grammar defines how to create a word in the language. There will be different types of languages, again based on different properties. For example, the context-sensitive, context-free, and regular language. And of course the type 0 language, which basically consists of all languages. Now those languages are defined in the Chomsky hierarchy. In addition to the different languages with the corresponding grammar, there are also machines or automatons, similar to the one in digital systems, where we had the Moore or Mealy machines. Remember those? There are deterministic and non-deterministic finite machines that are used for regular languages. Now, each non-deterministic machine can be converted into a deterministic machine. Another one is the push-down automaton, which implements a stack and is used for context-free languages. And the last one, and the most powerful one, is the Turing machine. Now, this course is fairly simple in theory, but in practice it can be a bit confusing or difficult to when you have to define a automaton or a grammar for a given language. Now, to some TU Berlin specific points, we will now get to the point where we can finally choose a few courses ourselves that we want to take. But there is a given rule that in your computer engineering bachelor's degree, you have to do a project course and a course with a seminar. So you have to choose a course that is one a project and another one that has a seminar or is a seminar. And of course, there's a minimum amount of credits you have to collect. More specific, you will have two areas of free choice courses. Now, the first one consists of a few catalogs that are computer engineering related topics. And the other one is where you can literally choose whatever you want. In the latter, I would recommend choosing a rather simple but yet interesting course. For example, choosing to learn a language. I personally chose to learn Chinese, for example. Now, the other part is pretty interesting. It has a few quite interesting topics related to computer engineering. Now, I won't be able to go through all the courses, but I, for example, chose in my fourth semester a project course in IIoT and 5G. Now, I chose the project in my fourth semester because the rest of the semester was fairly simple and not that demanding, and I knew that the fifth semester, for example, will have the operating systems practical course, which is quite demanding. And I really recommend doing the project in this semester because projects often are one of the time-consuming courses, and it really was in my case. But I can show you a few random examples. Okay, now I'll try and improvise a bit and show you a few modules that the catalogs offer you that you can choose from. For example, if you take a look at the computer science catalog, which has the most courses to offer, there is the 5G and IIoT project course, for example. This is the one that I did in my fifth semester. Now, currently, for example, I am doing the AI course, which also has a bit of fundamentals in machine learning, which is quite interesting, and it has a seminar. So you can see that I have already finished my project course and am about to finish my seminar course. Let's take a look further down, and we will see, for example, a course like Applied Computer Vision, which, in my opinion, sounds pretty interesting. And there's more about IoT, and there's Machine Intelligence 1, and somewhere down here here it is, Robotics Fundamentals. Those are a few of the courses that, for example, in my opinion, sound really interesting. And I will try to do the Robotics Fundamentals course next semester, but due to the whole pandemic situation, something like a robotics course can be quite difficult. But yeah, this is the main purpose of those catalogs, just to look at the courses that the technical university offers. Now, for example, if I go into embedded systems, here there are quite a few less courses, but you may see that, for example, but you may see, for example, that the robotics fundamentals course is also here in the catalog for embedded systems. This will happen with quite a few of the courses that they overlap in the different catalogs. Or if we go into the electronics and information technology catalog, you will see also again the 5G and IoT project, for example. And I myself tend to go into the computer science direction, but That's why I don't really go into this catalog. But yeah, I will try and link the the summary of this of those catalogs in the description below, and you can try and take a look yourself if I manage to do so at least. And let's continue with the rest of the video. And yeah, so guys, this is the first semester where, at least when you follow the recommended course plan, you are able to choose your courses that really interest you. Now, don't forget that this is a bachelor's degree, so you are here to learn broad fundamentals, and really interesting or more in-depth topics will come in the master's degrees, where you can almost choose everything freely. Okay, enjoy this semester, stay excited, and try to find always new things that interest you and learn about those. And with that said, thank you very much for watching. I hope you enjoyed this video and it brought you some value. And see you guys in the next one. Bye!